Today we are going to start arithmetic progression. Arithmetic progression, which is also written as AP, arithmetic progression. Now we will see one example here first. 2, 4, 6, 8, 10 and so on. Now what do you see from these numbers which I have written here? You can simply say these numbers are written in an increasing order of 2. This is the simple way of the explanation of these numbers which I have written here. Yes, it's very true. These numbers are written in increasing order with the difference of 2. So these kind of numbers which is written in the increasing order with a constant difference in between the two term, that is called arithmetic progressions. Now if you see these numbers, what do we see here? If we see second and first and second terms, second, third, we can see that in each term we have the constant 2 being added. Constant 2 being added. So a series of number which is obtained by adding one constant term to the preceding term is called arithmetic progressions. What did I say right now? A series of number which is obtained by adding a constant term is 2 to the preceding term. This is preceding term for 4. So I have added 2 to this first term to get second term. Now again I have added 2 to this second term to get third term. So on the terms of the series of a number which is obtained by adding one constant number is called arithmetic progressions. Or in another way also we can say, if the difference of the two terms of the series of number is constant, then that is called arithmetic progressions. Meaning is same. If, what did I say right now? If the difference between the two consecutive means just one after the other, two consecutive terms of the series of number is constant, then we say it is a arithmetic progression. Now see, this constant we generally write it as D. First term is generally, this is the simple terms, first term we denote it as A, right? Now in this case, suppose I have to find out the fifth term, if I have to find out the ninth term, 10th term, 12th, 13, we can find out by adding the constant number 2 to the terms, and then we can get the terms. But suppose if we need to find out the terms which is like 100 terms, what will be the 100th terms of this series, what will be the 1000th term of the series. So if the number of terms which we need to find out is very big, I mean to say the number which is we cannot find out by adding the constant, then we are in need of finding the formula. So for finding the formula, because suppose this is till nth term, we write here Tn, the last term. Tn means it can be any terms, and we have to find out the nth term. Now we are going to obtain the formula for these arithmetic progressions. Suppose we have got the first term here A, then the second term we will obtain by adding constant terms, that is A plus D. Then the third term again is going to add, this is added again, the constant we are adding here D. Then we get here third terms, and so on. This is a plus, suppose this is the n terms, we are writing here, so on. This is the we can write here a plus, this is the nth term, or simply we write down here till n terms, right? So this is first term, this one is second term, this one is third term, and so on. Now what do we see here? This is first terms. For finding the second terms, a plus, we are writing here d. Now what does it mean? D, this is second terms, then the number is 1 less than the first terms. So whichever term we need to find out, then the d is 1 less than the number that terms, like second terms, then the d is 1. Then here also we say third terms, then the d is 2, means d is always 1 less than the terms which we need to find out. Whichever terms we are finding, d is always, d value is always 1 less than the terms which we are finding. So here also the same thing. Suppose we are n terms, then the d will be 1 less than the terms. It will be 1 less because d value is always 1 less than the number of terms. If we are finding the third terms, then the d is 2. If we are finding the second terms, then the d is 1. So here what we are writing here, Tn equals to a plus n minus 1 d. This is a simple formula, just with the logic of adding d. This just with the concept of adding d and how we are adding d, we have found the formula for the nth term of the arithmetic progressions. Because this is the first term, second term we have obtained by adding the constant d, then the third term we have also obtained by adding constant to the preceding term, that is d, that is a plus d. Then we have again added this d to get the third term. If we need to find out the fourth term, then again we will add d, then we will get the fourth term. So what we see, the relation between the number of term and the d. If you see the relation between the number of terms and d, then we can clearly see here that d is 1 less than the number of terms. We are adding 2 times d in the third term, we are adding 1 times d in the second terms, and so on. So it means very clear that whichever term we need to find out, the d value is 1 less than the terms which we are finding. Suppose if I find the 99 terms, then the d value would be 1 less than the 99 terms, that is the d would be added 98 times, because third term d is added 2 times, fourth term d will be added 3 times, fifth term d will be added 4 times. So similarly I have written here n terms meaning the n I have written for making the formula. N can have any value, 1, first, second, third, fourth, fifth. So n terms we have generalized. N terms if we need to find out, then we are going to add how many d's will be added. Whichever term we are finding, the d is always 1 less than the number of terms which we are finding. Say here n terms, so d will be n minus 1d, and we are adding first term because every term is obtained by adding the d to the first term. So we are adding d to the a plus n minus 1 d. So in generalized, we have generalized the formula as Tn equals to a plus n minus 1 d. We can check. Suppose we need to find out here second term, then a plus second term, this is n minus 1 d equals to a plus d. This is second terms. Suppose we are finding here third terms, then a plus 3 minus 1d to d. This is third term. So now we are in a position to answer any of the term values without adding d. This is the general formula for finding out the values of the nth term of the arithmetic progressions. For finding the arithmetic progressions, what all things we need? A is the first term of the series, then is n number of terms which we need to find out, and d is the constant difference between the two terms. I hope it's very clear to all of you. Just have a look, and if you have got any doubt, you can ask me. Okay, thank you.